Okay, so to finish off polars and complex numbers, we need to do roots. So we've done multiplying, dividing, we've done powers, and now we get to do roots. So if you have a complex number in polar form, it should look in the form r times cosine of theta plus I sine theta, and you're trying to raise it to a positive integer root, then the root should look like this. You should take your r to the root power. The 1 over n, remember, is like the 1/2 power square root. 1/3 power is cube root, and so on. And then you add on 2 pi k over n. So also another thing to notice here is up here that if you are trying to find the nth root, there are indistinct nth roots. So if it's a square root, you should have 2 square roots. If it's a cube root, you should have 3. If it's a sixth root, you should have 6. So this process is a little tedious and honestly slightly annoying, but not impossible. Okay, so we have the fifth root. That means we need to find 5 roots. So once I see that this says fifth roots, I know I need 5 answers. So in order to do that, we are going to take 1 to the 5th power, which is just 1, and then you're going to do cosine plus I sine of your angle that you start with plus 2 pi k over 5. Now, I didn't say this in the last one when we were actually looking at the formula, but this k is going to be a positive integer, and you're going to get to 5. So you're going to start with 0. So really here the idea is you're going to 1 to the 1/5 power is just 1. And then you're going to plug in 0 to that. So you're going to have pi over 2 plus, well, wait a minute. Wait. Let's go back a step here a minute. What I would do is I would split it up into 2 things. So take the pi over 2 divided by 5. So that would be pi over 10. And then the 2 pi k divided by 5. So like I said, the first time you're going to start with 0, and that's going to give us our first fifth root. So 1 cis pi over 10, because that k is first 0. And then you're going to keep going up till you get all of your roots. So then we're going to take pi over 10 plus 2 pi times 1. So k is going to be 1 when you plug it in over 5. So I'm going to have pi over 10 plus 2 pi over 5. 2 pi over 5 is 4/10. That ends up being 5/10, or pi over 2. So here's your first fifth root. Here's your second fifth root. We still need 3 more. 1 cis pi over 10 plus 2 times pi times 2 this time over 5. So this one was times 1 up here. And so now we have 1 pi over 10 plus 4 pi over 5. 4 pi over 5 is 8 pi over 10. So this would be 1 cis 9 pi over 10. There is a pattern to these. So once you start seeing the pattern, you can just go like this. This first one is 1 pi over 10, then 5 pi over 10, and then 9 pi over 10. So you're going up by 4 pi over 10 each time, which makes sense. You're going up by 2/5, which is 4/10. So our last answers are 13 pi over 9. If you were to plug in 3, not 9, why did I say 9? 13 pi over 10. And our final answer, I don't really have room to write it over there, so I guess I'll write it over here. We go up another 4, which is 17 pi over 10. So you have 5 fifth roots of 1 cis pi over 2. I hope you can find them here. Let me put them in a better. So here's your answer. Here's your answer. Here, here, here. See how they're all going up by 4 pi over 10? And the reason that is because of this right here. We took 2 pi k and divided it by 5. So 2/5 is the same thing as 4/10. So each one you add on 4/10 each time. So you would go k equals 1, k equals 2, 3, 4, and 5. Fun stuff, right? As I hear your groans in the background, even though they're not there, which makes this a little depressing to me. But oh well, we will move on, I guess. Okay, so the next one says we're going to do 4 root 3 plus 4i. I'm not sure there's any like this on your homework, but I just thought I would show you this. We're going to keep these answers in polar form because your answers are going to be like 18ths. And in order to get 18ths back into complex form, you would need a calculator. So I'm just going to show you how to do that without, and we'll just leave them in that polar form. So you would take the square root of 4, square root of 3 squared. We're changing these into polar form first, which is equal to the square root of 64. So 4 squared times 3. So 4 squared is 16 times 3 is 48 plus 16 is 64. So that's 8. We would also need our angle. So the tangent of theta equals 4 over 4 square root of 3. That angle would be pi over 6. So in polar form, this is 8. This is 8 cis pi over 6. To find the cube roots of this, since we have the cube roots, we need 3 answers. So we need to take the cube root of 8, and then we have pi over 6 plus 2 pi k divided by 3. That 3 because we're doing the cube roots. So what this ends up being is 2 cis pi over 18 plus 2 pi k over 3. So we're going to be adding 2/3 to pi over 18. So we're going to have 3 answers. The first one is where k is equal to 0. And so it's the simplest answer, 2 cis pi over 18. If you're sitting here watching this video going, man, this is a lot of work, and why the heck would we ever need to do this? Well, as I've told you like 4 times already, electrical engineers find this fun or they need it or something like that. That's what I've heard. Don't know how true that is. Okay, so the next one we need k is equal to 1, which really means we're going to be doing 2 cis pi over 18 plus 2 pi times 1 over 3. So we need to add 2/3 to pi over 18. 2/3 is how many 18ths? 12 18ths. So that would be 13 18ths. And then the last one would be k equals 2. And that would be 2 cis. We need to add another 12 18ths to it, so it's 25 18ths. If we needed to change this back into complex form, we'd have to use a calculator because 25 18ths is not something we could do with that. And remember, we would do cosine of 25 pi over 18 plus I, and then we'd figure out sine of 25 pi over 18 and then multiply n by 2. Okay, I'm going to do one more number just for fun. So if we want to find the 6th roots in complex form of negative 729, this means we need a lovely 6 answers. I hope I have enough room on the screen to do that, but we're going to try. The good news is this one isn't so bad in terms of finding this in polar form. So we would have to take the square root. I'm going to try to save some of my room. 729 squared plus 0 squared, which is 729. And if I had the tangent of theta, our I part is 0 over 729. So where does theta equal 0? Well, theta equals 0 at 0. So in polar form, this number is 729. Oh, well, that was nice. I think I keep hitting the mouse pad while I'm writing on my screen. Okay, 0. To find the 6th roots, I'm going to take the 6th root of 729. I would not expect that you knew that in your head, but maybe you do. And then just to show you that you can do this in degrees as well, it would be 360k over 6. I guess technically we also divided that 0 by 6, but 0 divided by 6 is 0. So the 6th root of 729 is 3. The first one is 3 cis 0. And then if we were to keep going with this, this would be 3 cis 0 plus 360 divided by 6 is 60 k. So what that means, maybe this might make more sense to you in degrees than radians because you don't like fractions still, even though I've tried all year, is that we're going to just keep going 60 more degrees each time. So our answer is 3 cis 0. Then we're going to add on another 60. That would be where k is equal to 1. And then we're going to add on another 60. So that would be 120. And then we would add on another 60, which would be 180. Then we would add on another 60, which would be 240. And then we would add on another 60, which would be 300. If we needed to find out what all of these were in regular format, we could do all of them. I'm not really wanting to spend our time on this video going through all of those again, but you could if you wanted to. Let's see. You know how I am. There we go. That's better. Okay. So those would be your answers, but we could turn all of those back into complex form if we needed to. Is it bothering anyone that there's a parentheses around 1 and not all the rest? So let's just fix that real quick. So here would be the 6th roots of negative 729. I think that's it for the week. You have one shorter delta math assignment on this stuff, and then a longer one on all of polars to do as well. So let me know if you have any questions. Thanks.